Hi guys, I want to work these two examples on page, I guess we're on page 55. Move this guy. Yeah, 55. And explain to you the difference between these two. They are both and examples of an and inequality. Whoa, that is too black and too fat. This one's an and also, but I'm going to work them differently, and I'll tell you why when I get down to the second one. So this one, I see a bunch of fractions. We're going to clear out the fractions. It's so much easier to deal with integers than fractions. So I'm looking for a common denominator, which of course is 12. I'm going to multiply this whole thing through by 12. So when I do that, I am going to end up with 5 less than 2x plus 15 less than or equal to 11. If you need help getting to that point, come and see me. You should be able to do this pretty quickly on your own by now. So I'm going to subtract 15, trying to get the x alone, subtract 15 from all three of the terms, and I end up with minus 10 less than 2x less than or equal to, what's that, minus 4? One more step to get the x alone, division. I'm dividing by a positive number, so I don't have to worry about flipping the signs. Minus 5 less than x less than or equal to minus 2. So this works nicely, and if I asked you to graph it, there'd be no problem. Remember that you were looking for the points that make both of these conditions true. So negative 5 is the target number here. Negative 2 is the target number here. That one is filled in. This is an open circle, and basically everything in between the two target numbers will make both of these inequalities true. That's what an and condition needs. Okay, let me go down and show you the second one. So this is an and condition also, and you could say, okay, well, I'm just going to start by adding 5 to all three terms. But what I want you to notice that's different about this one is you've got variables all over the place. So when I have variables in all three terms, I rewrite it, and I just work two totally independent problems. So I take 2x minus 7 less than 3x minus 5, and I take 3x minus 5 less than x plus 11. It's simpler to me to do it this way. I've got to get my variables together, so I'm going to subtract 3x from both sides. I end up with a negative 1x minus 7, or maybe you just write negative x. I like to include the 1 sometimes, not partial. Minus 5, add 7, carry on, and you end up with minus 1x less than, am I doing this right? Let's see, what do I have over here? 3x minus 5. Okay, so that would be less than 2. Okay, so let me just go back. It looks different on my sheet than I did here. Have I done this right? Minus 3, so plus 7, minus 5, looks good to me. Okay, so now I need to divide by minus 1, which flips the sign, and I get x greater than minus 2. On this side, I'm going to come over and work this dude. I'm going to add 5 to both sides, get 3x less than x plus 16, get the x's together, I'll subtract him, I end up with 2x less than 16, divide, and I don't have to flip the sign because the coefficient is positive, and I get x less than 8. Now I got to put these back together again as an algebraic statement. So I need x to be less than 8, but he needs to be greater than negative 2. Here's my algebraic statement, and I can graph it as well. Negative 2 is a target point, positive 8 is a target point. They're both open. And in order to solve both of these, this guy and this guy, it's the points in the middle. Hope this helped. And we'll work some more of these in class. If I made a mistake, Let me just go back up here real quick and see. I wrote it down right. Get the 3x's minus 7. Yep, I think it's good to roll. Okay, see you in class, and we'll do some more. Bye.